So what I suggest you guys do to start is go ahead and pause this video right now and take a moment and copy down these 1, 2, 3, 4 rules for dealing with and simplifying exponents. We're going to use each one of these in the problems that follow, but I want you to have a visual reference of these so that you can keep looking back at them and comparing them to the ones with numbers in them. So now that we have these written down, let's go ahead and move over and look at a couple problems that we could use to simplify some expressions. So first of all, I like to look at these in two ways. I like to look at them in terms of the rules, but also I like to look at them in terms of just logic and reasoning. So when I see x to the fifth, I understand that means that I have 5 factors of x. There are exactly 5 of them. So I could write x to the fifth out as 1, 2, 3, 4, 5 factors of x. And when I see x to the third, I understand that that's 3 factors of x. So I could write out an additional 1, 2, 3 factors of x. When I have them written out like this, I can count how many factors I have. And I have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 factors of x. So let's be clear. When I multiply x to the fifth times x to the third, that simplifies as x raised to the 8th power. Now, the rule that we have says that if you're multiplying 2 bases that are the same, and you want to combine those bases, right, what you do is you add the exponents. So, this is like intuition based, right? What does it mean? I've got 8 factors of 8. Rule based means that I could look at this as x to the 5 plus 3, where I'm just adding this value 5 and this value of 3. So that's the first one, and you can see that rule it's written right here, right? X to the a times x to the b is equal to x to the a plus b power. The next one that we have is where we're writing a power to a power. So if you look at this here, I've got 2 identical factors of x to the fifth. So now I'm just going back to what does an exponent means. This number up here tells me how many of these things I have, and I have 2 of them. So I can write them out. I've got 1 of them, and I've got another 1 of them. This is supposed to be a 5. And I've got another 1 of them. So all of a sudden, because I understand that this 2 means that there are 2 things that are just like that, 2x to the fifth, I can write them out. And now that I understand that, using the previous rule, I can go ahead and write out one of them as xx, xxxxx. There's 10 factors of x there. I can count them all up, and there's 10. Using the previous rule, I can say, oh, this is x raised to the 5 plus 5, or x to the 10th power. But using the rule for a power raised to a power, I know that this is x raised to the 5 times 2 power, which is x to the 10th power. So in either case, I get the same answer, right? It's x to the 10th. Either by thinking about it and counting them, or by just using the rule and multiplying. So that's how I deal with multiplying powers with the same base. That's how I multiply raising a power to another power. Next thing is I want to talk about what do we mean by a negative exponent. So on the previous page, I had a formula written down, but I want to look at just a couple numbers. If I take this 2 and I raise it to the negative 1/2, 2 raised to the 1/2, to negative 1 power. Hello, Mr. Roberts, are you here? Yes, thank you. 2 raised to the negative 1 power is equal to the fraction 1/2. If I have 2 to the negative 2 power, that is equal to 1 over 2 squared, which is of course the same as 1 over 4, right? So again, using this rule, like with a negative exponent, what happens is it becomes a positive 1 once I move it into the denominator. So x to the negative 1 is equivalent to just 1 over x. And I can extend that, right? X to the negative 2 is equal to 1 over x squared. And if I really want to, I can extend it and use a variable, and I can say x to the opposite of a is equal to 1 over x to the a power. Okay, and that looks like a 9, but it's not. The last of the 4 rules that we had, and then we're going to start burrowing into a little bit more complicated examples, is what do I have when I have a quotient, right? I have x to the fifth divided by x to the second power. In terms of rules, you wrote that down and it's already on your paper. In terms of writing this out, I know in the numerator I have xx copies of x factor, 5 factors of x in the numerator, and I have only 2 of them, xx copies of the factor x in my denominator. And because there are common factors here, right, I can cancel. I understand as I cancel out common factors, I'm always left with a factor of 1 behind. This simplifies to x to the third power. And if I wanted to, the shortcut rule tells me, oh, if you've got the same base and it's a quotient, it's a division problem, that's equivalent to x to the fifth minus 2, right? Which is equal to x to the third power. Again, one of them is just intuition based, one of them is based on using these rules. So if I look at this here side by side, I have examples of things that I consider to be simplified and things that are not simplified. As you look at it, one of the things I want you to see is in simplified expressions, right, that involve exponents, I never have any negative exponents, right? You can't see a single negative exponent in the ones where it's simplified. Now, on the ones that are not simplified, I definitely have negative exponents, and I also have a product raised to a power, and I also have some common factors. So what we're going to do is I want to look at the ones that are not simplified and simplify them. So using our understanding for what a negative exponent is, how would I simplify x to the negative 2 power? Yeah, John. That's exactly all it is, 1 over x squared. Now, what about the next one, right? Y squared, and then that's raised to the fourth. Yeah, Dominic?
Y to the 8th.
That's right, y to the 8th. We don't have to write it all out, right? If we're proficient with the rules, it's y to the 8th. The next one, I have a product, and it's raised to the fourth power, so if I was to simplify that, what would it be? Perfect, yep. S to the fourth power times t to the fourth power. And then on the last one up there, can someone tell me what we can do, what's possible with that last one? Someone maybe from the farther side of the room. Hello, Nick or Caleb. Okay, go ahead. That's very good. We had a common factor of what in the numerator and denominator? Common factor of 3? Of 2, thank you. So we'll finish with this. This was a problem that was in, I guess, last night's homework. And this is why we're going to spend a little bit of extra time looking at simplifying some things with exponents. So I'm going to call on a couple of you and have you just take care of individual parts of this. So let's look at part A first. So if I want to get rid of the fact that this is, the first part is raised to the 8th power. Jacob, what would this become if I was to make that to the 8th power go away? And that's the only thing I'm focusing on right now. Let me start with, it would be like 5 to the 8th times, keep going, a to the negative 16th. Excellent, b to the 24th. So that's an excellent first step, right? Go ahead, the next part. Oh, let's not write that down. That's too big of a number. Let's keep going, though. The next one, let's go with Elise. Yeah, we're still on A, but I want you to get rid of that to the negative 6th power. Just by doing what we did, we're going to multiply each one of these, their exponents, to that value. There is going to be a positive 12 for B, but 5 is going to be raised to the negative 6th. Can you tell me what A is going to be raised to? Also, that's right. And then B is going to be to what power? to the 12th power. Okay, very good. Now, when I look at this, guys, are some of these exponents negative? Yeah. What we do with the negative exponents, look at that, the rule that we have, negative exponents, it's that reciprocal property, right? So those ones that are negative, I'm going to write in my denominator. So I'm going to have a to the 16th in my denominator. I'm going to have a 5 to the 6th power positive in my denominator, and I'm going to have another a to the 6th in the denominator. In my numerator, I'm going to have a 5 to the 8th power, and I'm going to have a b to the 24th times a b to the 12th power. So, first things first, Nellie, can you combine those b's for us?
The two b's?
Yeah, how many b's do we have in the numerator when we're done?
36.
Excellent. So this is b to the 36th power. I'm going to still write the 5 to the 8th. In my denominator, there is a 5 to the 6th. Yeah, let's get Jasmine. How many factors of a do I have in my denominator? Yeah, 16 and 12 should be a to the 22nd power. All right, we're so close to being done, except I want to clean up these factors of 5. I've got some 5s in the numerator and some 5s in the denominator. When I clean them up, how many factors of 5 am I left with, and where are they? 2 in the where? 2 in the numerator. So my final answer is going to be 5 squared times b to the 36th power all over a to the 32nd power. Oh my gosh, to the 22nd power. I can't even copy. It's right there. I'm just bringing the 22 over. All right. So I want you guys to finish off and try to do the same thing with b, right? Just finish that off. Tomorrow in class, when I see you, then we're going to be practicing about the same thing, practicing the same kind of thing. So make sure you jot that one down. Have a good evening.